This is a short video tutorial on the kinetics, talking about orders of reactions. And there's a couple different kinds we're going to address. The first one is just talking about the initial reaction rates. And you can only determine that from data given to you in data tables. You're given an experiment, and the rate law would be rate equals K, which is the rate constant, times the concentration of A, whatever that reaction is, to the n power, which is whatever order it is, times the concentration of B to whatever power or order it is. And this is for each experiment. There'll be different concentrations, but the order should remain the same. Now, if it's a zero order, that means that if there's a change in concentration of a reactant, there is no effect on the rate. They're not very common. You're not going to see them very often on the tests. I don't like them very much, but sometimes they'll slip one in just as an easy, because it's zero, its rate is equal to K. That's it. First order, most common. You're going to see it a lot. Basically, you double the rate. You double the reaction concentration. You double the rate. Very, very easy. And most often rate is equal to K times the concentration of just one of the reactant. Either there is only one reactant or there's a couple of them, but only one of them is a first order. Finally, the second order, a little bit more complicated, but if you take that concentration and you let's say you double it or you triple it, then the rate will be square of that. So if you tripled the concentration, if you square that, then you get 9. It's going to be 9 times. The rate will be 9 times greater. If you quadrupled the concentration, then the rate would be times 16. I mean, it's square of whatever you have. You get them in some gas phase reactions, which means we're not going to see them very often. And the form just means that you either have squared your one reactant or you have two reactants that are first order. And so you get a second order for the whole reaction. So let's just talk about real quick the initial rate, if you're talking about initial data. And you're given a data table and you have to figure out the order of each reactant. You need to be able to do this numerically, and I've kind of set one up for you there. If the A is kept constant between experiments 1 and number 4, and the concentration of B is doubled, what happens? When you do that, you see that the rate is 1/2, and the concentration is 1/2 to the n power. Well, that 1/2 is equal to 1/2 basically, so n has to be equal to 1, which means it's first order. So B is first order. You do the same thing for A. You should run through it, just double check mathematically, but you're going to find out that A is 0. So what we would say is that with respect, the reaction order with respect to B is first order. The reaction order with respect to A is first order, or oops, that should be 0 order. Kind of a typo. I'll fix that later. These are differential rate laws. They're using concentration and rate data. So you get the table, the data table, you use the logic from the table and some algebra. However, once we get further into the questions or into the unit, they talk about the integrated rate laws. And these are using concentration and time data. And now you're going to be graphing them. So here's the basic table of information that you should memorize for each of the order, 0, first and second order. Pay special attention to the integrated rate laws. They have a y equals mx plus b form that you're going to use to make graphs. And again, first order is the most common. When you get a linear plot, that graph, it's going to be natural log of the concentration of A versus time. The slope of that is negative K. Remember that K is the rate constant. And so then they'll also ask you for the units for K. And if you look over here at the rate law, rate is equal to K times the concentration of A. A is molarity, right? And rate is molarity per second, which means that for that to be true, K is going to have to be 1/second or inverse second. So you can figure out what K is supposed to be. So they'll sometimes ask you for the units for that. This is different than the K that's used for equilibrium because that's unitless. This has units. Also, you might notice that the half-life, natural log of 2 over k, it's the same thing as if you plugged in your calculator, you'd see it's 0.693 over k. So, and that's also on the reference sheet. So you will have access to this, but you should definitely know it and know what you should be looking for. So here's some graphs that you can identify. If it's the differential rate laws, the differential graphs, if it's a zero order, because they're all concentration versus time. If it's zero order, it's just straight, concentration goes straight down over time. So it's a straight line. For first order, there's a slight curve to it. And for second order, it's a more drastic curve. They call it asymptotic, I guess, curve. If you do integrated, then you have the different slopes. Concentration versus time, just like it was for the zero order, because there's no effect, it's the same graph, and your slope is negative k. If it's first order, then it's natural log of concentration versus time. Still have a negative slope, that's negative k. And then if it's second order, it's 1 over concentration, inverse concentration versus time. And now the slope is positive, so it's a little bit different. And you can see the units of k there at the bottom and the half-life. So gives you a lot of the information there. So now with all this information, here is an opportunity to practice that. So the video is going to stop, but you should try to see if you can figure out the answers are all at the bottom. Walk through it. Initially, you'd have to make a graph, and I went ahead and make a graph for you. In the upper right-hand corner, this is a graph of the data. And you can tell by the data, by the concentration, it's going to be first order. There's a slight curve to it. It's not a huge drop, and it's not a straight line, so it has to be first order. So then I went ahead and graphed it for you to get the natural log of the concentration versus time. And I got you the equation of the line, and the r squared is equal to 1 to confirm that that is the right graph. So then you should be able to do A, B, C, and D, and double check your numbers down there. And then and just let me know if you have any questions, but that should be it. And that wraps up just the basics of, hopefully, review of the basics of the kinetics. And if this does not explain it, though, you need to let me know. Come and ask questions or email me. Thank you.